Government in this town is excellent and uses your tax dollars efficiently.
Nick Saponaro with the Divi project. And Nick has actually been here multiple times and done some great work for us with the orphanage nearby, actually teaching them how to build robots and work on computers and all kinds of cool stuff. So I really love having Nick around, and everywhere I've met Nick, he's been nothing but inspirational, for sure. So, Nick, welcome back.
Thank you. Thanks. It's always good to see you, Danny, and it's really nice to meet you, Colin.
Yeah, so we're going to find out some really cool stuff about Nexus and Divi today. So, well, let's just go ahead and start with you since you've got the mic. Where is Divi Project? I mean, you guys started out as this masternode hosting service, and then you shifted into the coin, and now you've got multi-wallet, coin wallets and all kinds of stuff.
Yeah, that's right. I mean, we really started the project with a philosophy in mind that we wanted to create a decentralized ecosystem that didn't sacrifice the decentralization for convenience. We feel that user experience can be implemented in a way that's familiar and accessible to people without having to go into a centralized, point of failure, basically. So yeah, in 2017, we did our ICO. In 2018, we launched our first product, which you mentioned is the Masternode one-click cloud installer, which has a patent pending on it now and allows people to deploy a Masternode right from their phone or their computer, of course, as well as staking, decentralized staking directly from a mobile device, which we launched last year. So yeah, it's been a wild ride, and we're happy to be back at Anarchapulco, of course.
Awesome. What all coins are you allowing for staking inside the Divi wallet?
Right now, you can stake just Divi, but we are adding 270 other assets toward the end of this quarter. So watch out for
one of them
for
being
some of your
Nexus.
favorites. Yeah, we'll have to talk. 100%.
I know Nexus has staking as well, so we'll find out more about that. And you guys are expanding in marketing, and what all you guys got going?
Yeah, we just closed our biggest deal, which was with the Spanish soccer league La Liga, which is going to put us in front of about 1.5 billion people every season of soccer, football. They call it in Spain.
Football.
Goal. So it's been awesome. It's a partnership at the scale of some of the people that we compete with at the highest level. And so we're really fortunate and blessed to be able to have a relationship like this.
Awesome. So you're marketing in Latin America. What is your focus in Latin America? What are you trying to solve with?
So it's interesting. The La Liga partnership actually spans 48 different countries. La Liga is a global organization, so we're actually more focused in the Middle East and North African region, Southeast Asia and parts of China and Japan, as well as some of the Indian subcontinent.
I'm just assuming because of having you guys here in the past years and talking with your partner about what's going on in Costa Rica and everything. So
yeah, absolutely. I mean, we have a beautiful community in Venezuela. Some things are starting up in El Salvador and throughout Central America. Of course, Costa Rica, where we're based. So yeah, it's always a focus.
What do you have going in Venezuela? Because that's definitely an area that needs it.
There's a guy in our community, Ramos, who literally has taken it upon himself to generate a circular economy using Divi within his village. And he started really small with some donations from our community that set up a masternode for him. And he uses that now to pay for goods and services within his community. And he's up to almost 500 people a week that he feeds in his village. Women, children, pregnant women, sick, elderly, things like that.
Awesome. That's
really cool.
Fantastic. That's what some of what I really love about these guys. Every time that you guys show up, you're doing something cool like that. And I do want to give a shout out to another project that we're doing here, actually in Bonfil. Epic Cash is donating money for us to build a bike track outside of the orphanage across the street, which will benefit all the kids in Bonfil. And they're also helping to clean up trash. Somebody had called Epic Trash, and I said, well, you know what? Let's just own that. We're just going to clean up the neighborhood and show you what Epic Trash really is. So, well, Colin, let's hear about Nexus. We want to know what a 3D blockchain is.
It's an architecture I've been developing for about 7 or 8 years. It essentially so let's look mathematically dimensionally, right? You have a line, single dimension, right? You can only hold so much data on that specific line if it's digitized, right? Digitized means you're broken into smaller segments. If it's analog, you have infinite numbers between 0 and 1. But, just in the general
Slow it
idea,
down into, yeah.
blockchains are single-dimensional chaining structures.
Right.
Okay? So you have a chain in one direction. So you either link forward or backwards, right?
Right.
Usually you link back so that you have to redo all the work to blah, blah, blah. And that's how you get immutability or probabilistic immutability. But a three-dimensional blockchain is taking it from a line into a shape, right? So instead of dealing in single-dimensional chaining lines, you have a two-dimensional lattice, okay? And that two-dimensional lattice then forms the foundational level. And then that passes up to different levels of consensus that check and balance one another so that it ends up, the best visualization of a three-dimensional block is kind of like a Rubik's Cube. You could think of it as like a 3x3 cube, right?
Right.
And so what it does is it allows you to do sharding in a safe way that also provides the scalability, and it's an organic structure that becomes a rigid multidimensional structure. So if you change anything in any part of that, then it all breaks, right? And so then you have this root cube. If you think about it perspective-wise, if you're looking at a cube or you're looking at a projection of it, you have the projection through the corners diagonally, right? So that root cube then can hold that hash that you have Merkle pass through into each level of this three-dimensional block. So the three-dimensional block can exist on computers all over the world, not necessarily replicated all on one individual computer, but everybody can do all of their verification of that specific transaction set or sigchain through that root cube, right? So it gives you the fundamentals of blockchain, but it becomes a multidimensional object, chaining in multiple dimensions so that we can expand out and have safe sharding without also having the issue of...
That's sharding with a D, not
D.
a T.
Yeah, so sharding is essentially breaking the data set into smaller data sets, but the problem with sharding in blockchain is, well, if you break your consensus up into multiple sub-consensus channels, you're going to reduce and degrade security. So what this does is that it creates a security model around all of the channels checking each other by passing their hashes to one another. So if I want to attack and rebuild a certain part of that, let's say, two-dimensional lattice, I would have to actually get the consensus of all the other people around me, right? So I can't just go rogue. So it makes it much more difficult to attack, and it changes the entire attack surface of the blockchain specifically. And it's our architecture to solve this blockchain trilemma, right? Ethereum's kind of doing it a little bit backwards. They're trying to do like the beacon chain, and they're making a beacon chain, and then Ethereum's going to be a subchain of a beacon chain, and blah, blah, blah. But you have these issues where it's like, okay, well, I need to verify a previous transaction in another shard. You're going to lose your sharding, right? You're going to lose the scaling of the sharding because you're going to have to start cross-shard communicating, right? So that's why it's a multi-level consensus system where you have the base level that's just creating the cryptographic links, kind of ledger-level links, and then that's verified on the next layer, the L2 layer, and that also can handle some of those cross-shard communications without actually having to have the shards communicate. So that way you allow the efficiency of the sharding, but you get the security of the blockchain and the chaining structure, right? Because in order to change it, think of it as a two-dimensional object, you no longer have just a single line or a number of blocks in that line to have to hijack. You actually have to hijack a two-dimensional object, right? Which is kind of like a lattice. So think of it, instead of thinking in lines, just think in shapes, right? And reality is multidimensional because you can store more information exponentially in it, right? X squared, x cubed, right? That demonstrates, you have exponential scaling capabilities by adding a dimension. It's exponent.
Right. Can you use this with shielded chains like ZK or Monero, or is this only something that would work with transparent chains?
I'm designing the architecture to have an upgrade path for legacy chains, right? The Tritium protocol has an upgrade path from a legacy Bitcoin-derived blockchain if you want to. So I'm developing it to have that pathway for other people to be able to utilize if they find it beneficial. Privacy chains, I'm not super hyped up on them just because I believe zero-knowledge cryptography hasn't gone through enough crypto analysis to be reliable. And the secondary is blockchains already don't scale, and this zero-knowledge cryptography doesn't scale times 50. So, we're compounding a problem to solve a very minimal problem. I think the fundamental problem right now is we need to be able to use the blockchain. And if it's slow, it's clunky, and it costs $5,000 to lose your Ethereum in a fee, right? It's not done. It doesn't work, right? It's not functional. So we're focusing primarily on just the transparent chain, three-dimensional chain. We'll get to more anonymous privacy shielding, like with homomorphic encryption and different things in the future, but it's still just too slow. It's just zero-knowledge cryptography, homomorphic encryption. Any of that is just too slow.
Especially when it's from Z to Z, but in the transparent transactions, they're actually fast.
You have trusted setup issues too. With
Right.
Zcash, you don't know how many people have minted. So there's all these other problems that have come from it. I see more problems than solutions with, those types of chains. Plus, I mean, the NSA, they love Monero. They love botnet. They love all that stuff. So you also create kind of a different precedence of like the community that's going to be attracted to that specific. So we're not ruling out privacy features. Like we're working on a privacy-focused operating system that's completely encrypted and, you know, practically really resistant to hacking, right? But, you know, so we're focusing on more practical privacy issues right now. Like, you know, cool, yeah, you're using Zcash, you've got private transactions, but if you're running on Windows or you're running on Mac, which most people are, you know, you've got a completely backdoored operating system that can be either hacked or they can come in and assess data. I mean, iPhones, you can take screenshots, you know, so I mean, even encrypted messengers on there. Does it really mean anything, right? So until we have our full operating system down to the bare metal, we can't really guarantee privacy. So building a currency around privacy on top of that, I see that as a later thing. And also, the bat to beat you with issue too, right? Anonymous cryptography is great, but it also gives them a narrative to use against us, right? If you have the transparency, at least you can say, well, nobody's going to want to launder drug money on this because it's transparent. They'll want to go to Zcash or they want to go to Monero, right? So that's the secondary thing is I just don't think it's time right now for us. But I'm not saying that everyone else. I'm very skeptical about new type of cryptographic techniques. And so I just personally believe it's too slow, it's not ready, and it hasn't gone through enough crypto analysis for me to feel it's reliable enough to put it into a multi-million-dollar, you know, economy.
Right. Okay. Do you want to talk about your consensus with?
No, I mean, this is interesting to me. So the, sorry, it is. Yeah. So the goal is both security and scalability with your, and decentralization. And you can, how are node operators participating in that? Like,
well, you have different types of node operators, you know, based on different resource inputs. So think about it as weight and trust. So everything will have a trust, which is your consistency, your proof, your track record of consistent contribution to the network, right? And that's how we were talking about old money, new time, right? We need to render the old money and able to buy the new time, right? Only new time should buy, or new money should buy new time. So that's part of the trust is part of the consensus. Like with Bitcoin, it's just, hey, I make the block with the highest weight. It wins, right? With us, like we already have this working in our staking system. It's a trust-based staking system so that you have to develop trust and you have incentive for that because you get a higher return on your staking rate. It goes from 0.5% to 3%, and then that adds into creating voting weight. So think of every one of these multi-layers. You have the L1, L2, and L3 layers, right? It utilizes mining, but not in a way where it's one miner rules all. Right now, it's somewhat of a decentralized dictatorship, right? I produce the hash that wins. It's higher weight than the other hashes. Everybody else's proof of work is rendered null and void, right? Only one miner's proof of work actually gets onto the chain. So you get the security properties because it's difficult and resistant to create those hashes, but all the other work is wasted. So the L3 layer works kind of like a share pool where all of the shares get merkled together, and they agree on a common data set, which is that root cube, right? And then the L2 layer is more of a stake-based weight. So you use your stake, and that helps doing this cross-shard communication. It acts as a check and balance on top of the L1 layer. And then the L1's just kind of your more generic processing nodes that are doing the shards, and they're just doing cryptographic functions, right? They're just verifying the cryptography. They're verifying your digital signatures and your hashes because your digital signatures are your biggest computationally intensive requirement, so that's what needs to be sharded fundamentally. About Nexus right now, the virtual machine, I've tested it in a live network over a local host to about 10,000 contracts per second, just single dimensional. Right, so the contract processing is very fast, so the L2 layer handles more of that. So you kind of break up this processing into multiple layers and checks and balances with different nodes and different roles and different weights, right? Because the way you combat Sybil attacks is by having a resource that's difficult to ascertain, right? And you'd have to amass more of that physical resource than everybody else in order to control the consensus. That's proof of work or proof of stake, right? Your weight is either the computational requirement, an electricity cost, or the coins. Does that make sense? No.
Yeah. No, I get some of it.
Yeah.
But a lot of it is way the hell over my head.
Just think about it is we have 3 branches in a government. Why? Because you need checking and balancing of power.
Right.
Okay. If power becomes concentrated, then you get issues. Bitcoin is concentrated into about a handful of people, like 5 or 10 mining pools, right? And then 5 or 10 developers. So it's become centralized and the power has become concentrated in that mining. But a lot of other people are neglecting mining because they're saying, oh, it's centralized. But mining produces a lot of security for a network. So we see that the mining isn't authoritative, it's supportive, right? In Bitcoin, the mining is authoritative. I produce this block with the highest weight. My transactions are above yours, right? I can double spend. I can finny attack you if I produce a block with more weight than your block, right? And that's one of the ways that it works, but it's also one of the flaws in how it works. And that's why I say decentralized dictatorship, because one hash rules all. And then everyone else's proof of work is useless, and they've got to start over a new round. Think about if you could capture all of the computing power of the Bitcoin network, right? And everybody kind of gets a little piece of that block in a decentralized pool. That's going to nullify the mining pools, which will help mining become more decentralized, and it will also capture more of the electricity usage, right? Instead of just using it to increase the computational cost of this problem, everybody works on the same problem in the same data set. Instead of fighting over different Merkle roots and different block hashes, everybody's working on the same root cube, and they're agreeing on that root cube as they work together. So if somebody wants to go off and try to create their own three-dimensional block, they're going to have to basically create their entire network of L1, L2, and L3 nodes, even as a miner. So the miners don't have authority anymore, but they become a supporting role. But the L2 doesn't have an authority either because they need the miner supporting role. So it's kind of the checking and balancing of powers in the consensus so that one specific entity can't gain control of the consensus as easily. And that's similar to how our consensus works now, but we're just doing it in a single dimensional, right?
So it sounds like you're trying to make things less complex, but this sounds very complex. Explain, one of the things that I'm still very curious about and I don't fully understand is what is a UTXO and how did you get rid of UTXOs?
UTXO stands for unspent transaction output. So Satoshi Nakamoto, I believe, I can't remember what chapter 3 or 4, splitting and combining values, right? The initial design of UTXO was for pseudo-anonymity, okay? You have the sum of your inputs is always going to equal the sum of your outputs minus the fee, okay? That's how Bitcoin works. So you don't know whose inputs go to whose outputs, right? That's UTXO. So if you get enough of them, like you got like Mimblewimble, they tried to do that on a block level, right? But Mimblewimble
one transaction per block.
Yeah, and Mimblewimble was actually broken through just network analysis. You just run a node, connect to every node in the network, and then you're like, oh, hey, I can see where everybody's transactions are coming from, right? So even that is easily broken. The feds have been doing forensic analysis on UTXO. So the initial design requirement, anonymity, has been broken, okay? So the fundamental design of it just doesn't really make sense anymore. So it's clunky, it's slow. Every one of those inputs has to have a digital signature, okay? So you could have one transaction, and I could be sending 1 Bitcoin, but I could have to do 100 signature verifications for that one transaction. And there's nothing in the protocol to really stop that. You'll just have to pay a higher fee, right? So it's really clunky, and it's really inefficient, and it's really easy to attack. That's dust spam transactions, right? Just a bunch of inputs, really low, 0.0000001 Bitcoins, right? Slam the network with it, and then the network's just exhausted. It's DOSed by constantly having to verify those signatures, right? ECDSA, the fastest I've gotten in a multi-threaded sense is about 4,000 signature verifications per second, right? So if you have people pushing like on an average of 10 inputs or whatever per second, you're going to take more time to process that specific block. So Nexus signature chain architecture is kind of like having your own personal blockchain, but you get the byproduct of it's a login system that uses public key cryptography, right? So it's still using digital signatures under the hood, but we're changing the key every transaction. With Bitcoin, you have to manually do that, or you have to create a new address, but a lot of people reuse an address. And once you have that bare public key, it's now vulnerable to quantum computers, right, which we've already discussed. Those will break Bitcoin keys in about 64,000 iterations, something like that. It's 256 cubed rather than 2 to the 128 for an ECSA key. So you get quantum resistance, you get a digital identity, but you also decouple your keys from your account identification, so you're able to recover your account and not have it tied to this one specific number. Because when you lose that number or someone gains access to that number, you're screwed with Bitcoin. Or if you send to an invalid address, it's gone. Or if you uninstall your Bitcoin wallet, you don't have your private keys anymore, the Bitcoin's gone, right? The SIG chains help make it more usable and easy and friendly and decentralized, but also setting the foundation for a kind of identification system where you can have your assets and you can have the different things you own and show a track record of events which establishes that trust, right? A type of reputation on the network that is a pseudo-anonymous trust. You don't know who is who, but you can mathematically verify if I'm talking to this person or I'm sending to this person, I can verify they are something or nothing, right? So you're creating a mathematical track record to help facilitate.
Are you still using private keys,
so
passphrases?
It creates a private key every single transaction, a new one. So you never use a key twice. So as soon as you make that transaction, your key is obsolete. So basically that gives you an additional security property. You can re-sign with the same key. Ethereum does it usually 2 to the 64, 2 to the power of 64, about 10 to the 18 digits, a number with 18 zeros. Just think about it like that. Times you can sign before you leak a private key. But still, it happens. Private keys can leak through signatures and, one-time signatures as well. So it creates a stronger security model. Plus, the public key is never known until it's used, and once it's used, it's now obsolete, right? So that gives you additional levels of quantum resistance, and then under that, you can actually change your key. So I can go to my SIG chain, I'd be like, oh, I want to use Falcon, which stands for Fast Fourier Lattice-Based Compact Signatures over NTRU. What that means, quantum computers can't break it, right? It's a post-quantum signature algorithm, or you can just use good old ECDSA, and you do it with the click of a button. With Bitcoin, it's not quite so easy, right? And losing coins is a huge problem. So SIG chains make it safe to use. You have a username and a password and a PIN, and the entropy of that is what's used to generate your series of private keys. And then you have a recovery phrase that's also a secondary authentication that allows you to change your main authentication hash. So if you lose access to your account, forget your password, you use your words, you can take your phone, throw it in the ocean, go log into your Nexus SIG chain, and your coins will be there, right? So that same concept of decoupling the hardware from the actual, account, I guess you could say, is also what's going to go into the operating system.
Isn't it just easier to break somebody's password than it is to break their private keys?
Depends on how good your password is, right? And we use a memory hard Argon 2 hashing function, so you can't really, even if you use an 8-character alphanumeric password, your PIN was compromised and your username was compromised, it would take on order about 10 million years, even with a GPU farm, to actually calculate it, because we use a specific password hashing algorithm. So it takes about 1 second to create a transaction on Nexus to generate the key, because you have to go through this intense memory-intensive computational, hashing function to create this new key. And so you do have the leakage potential issue where, it's easier to break that than a private key, but in the other sense, it's easier to break a key from a quantum computer, or you can just use a hash that's the size of a private key for your password and paste it in there, and it's far more secure at the same bit length. So let's say if I use a 256-bit password like my private key is on Bitcoin, you're going to have still, I think, about 100 times the brute force resistance than a Bitcoin key, because it only takes about 2 milliseconds to generate a Bitcoin key pair. To try to brute force it, it takes at least 1 second to generate a Nexus key pair. So you have a larger computational bottleneck. So if you want to be paranoid and have that 256-bit password, you can put it in there and you'll have a higher security model, just because the key derivation algorithm is a lot slower on Nexus deliberately, because that's the way you throttle somebody trying to hack somebody's account in a decentralized way. Right? You can't have a central, hey, you've tried too many times, I'm going to kick you off, right? You have to have a computational limit, a computational cost in order to try to break it. And that's why we use a specific algorithm, because ASICs and FPGAs have no advantage over a CPU trying to attack and brute force those SIG chains. And then the secondary benefit in comparison to Bitcoin is a Bitcoin key being reused has the potential to leak some of that private key data, and also reveals that public key, which makes it vulnerable to quantum computers at the same time. So not reusing the key makes it that much more secure, because you don't know the key until you use the key, and once you use the key, it's obsolete. So there's very, very difficult, even with a quantum computer, and if somebody opted in to still use ETSA, you still wouldn't be able to break it, because we use post-quantum encryption too over the network layer. It's called Saber, which is another post-quantum algorithm for a key exchange protocol. So we're looking at all of these angles, but the biggest thing was like the design requirement of it needs to be easy to use. And there's so many horror stories of 50 Bitcoins, 100 Bitcoins disappearing because you download the Bitcoin wallet and you think you got your Bitcoins on there, and then you uninstall the wallet and they're gone, right?
Wow. But you can recover it with just the password. Huh?
Basically, yeah, or a recovery phrase, or just log in, or go throw your phone in the ocean and go get another phone.
I'm going to
just
keep
log
my
in.
phone.
So it decouples that idea that your coins aren't actually on your physical device anymore. They're kind of in a mathematical, deterministic hyperspace, and your credentials give you that access, that entropy to that space, and nobody knows where that space is, right? And that ties into the operating system design too, where it's a decentralized, distributed operating system, where your computer won't be your computer anymore. It'll be your SIG chain, or connected to your SIG chain. So you'll be able to access your files and everything else from that login identity. So you could go take your computer and throw it in the ocean when it's running LXOS, and then you just go buy a new computer, log in, and your computer's there. And then you can add devices to it. And so it's the foundation of many other things that are coming through the operating system and the routing protocol, and also, just simple identification systems.
Like, you guys are just building all kinds of services on top of Nexus. What are some of the other services? But I know Tritium is kind of an
it's
Ethereum
a
model.
protocol, yeah, and it's a smart contract language, register-based virtual machine. like comparatively to Ethereum or others, they use a stack-based virtual machine, a lot of big number arithmetic. We're a 64-bit register-based virtual machine. So the Ethereum instruction on average is about 1.7 million nanoseconds per instruction, right? Nexus is 33 to 40 nanoseconds. So it's, runs, depending on the computer and your memory speed, 40 to 80 megahertz on the actual virtual machine. So it's extremely fast because of just these little architectural adjustments that we've made, right? Which makes it a fairly effective, contract platform, and it's also API driven. So you don't need complex coders. You don't need to know all these different languages with all these weird nuances. If you ever read the Ethereum documentation, it's like, hey, do this. Oh, wait, but don't do that, because if you put this in here, then that's gonna happen. I mean, I was reading. I'm just like, wow, dude, this is man. It reminds me of my code when I was 12. It's just like, oh, hey, this is cool. I'm gonna put this in. I'm gonna make tank tracks now. Oh wait, I'm gonna make fire over here. Oh, cool, I got this over here. And you just keep adding the shit in. But when you don't foresee how it all fits together and spend the time to really architecturally design it, what happened to one of my first video games I was making, got to about 10,000 lines of code, it kind of went, it just wouldn't turn on anymore because I just kept adding stuff. And that's what their virtual machine really looks like is, oh, we need this functionality, let's add it, let's shoehorn it in. They didn't really think it all through. They claimed 256-bit virtual machine as some achievement, but it's actually not an achievement because now you're running 4 times as slow because you have to operate on 64-bit words at a time to even do that computation, and you have to store all of that data. So it takes 32 bytes plus 32 bytes plus 32 bytes, 96 bytes to do 1 + 1 = 2 on Ethereum, right? Because they're storing it all as 256 bits. But when we get in, remember 2 to the 64, 10 to the 18, it's like, 5 quintillion, that number? You will never, ever, ever in practical real life use a number bigger than that in any real world contract value. Like, you got millions, billions of people, right? You got trillions of dollars, but we don't want that, right? I mean, that's inflation, right? So you got, that's where we kind of made some of these design decisions is 64-bit is not amortized. It fits directly in with the processor architecture because processors use registers. They don't use stacks. The stack machines are similar to those old tape computers, if you remember those old tapes.
Right.
And it pushes and pops from the stack in order to maintain some of the values and do the computation on it. And that's really because they kind of copied the Bitcoin script engine, which Satoshi designed, and he used big number arithmetic because he wasn't really designing it to scale. It was just a prototype, right? And then they kind of took that and said, oh, hey, what if we add loops and make it Turing complete and then add this really higher level language that compiles into this bytecode? And it was a cool innovation, but I've seen a lot more problems created than solved from it, right? So we've kind of sat back and watched those problems manifest and make sure we don't make them ourselves. So that's why it's API driven. You can use a web developer. To make an NFT, it takes 2 minutes in a web browser if you want, or you can hire a web developer and make an interface. I've just been working on a decentralized search engine for Ernie to search his IPFS files. That's just done, but you can query the Nexus blockchain. I wrote a actual SQL-like DSL. It's a domain-specific language, so you can actually query any level of data on the blockchain without having to scrape it into an external database. And you can do statistical functions, Excel functions, like accounting features just right in the API. Mm-hmm. And you can also select specific contracts that you want to utilize, kind of like templates and standards, so that we can just make crypto safer and developing safer and also lower that barrier of entry for people that want to build their platforms. And we've actually got a carbon credits trading platform and full trading marketplace, like taking on the big names. And he didn't touch a line of code. He built it in this no-code tool called Bubble and built a plugin that just drops right in the Nexus API, and boom, he's got a full carbon credits trading platform without touching code. That's one of the most beautiful things I've found is being able to create that availability for people to bring their dreams to life that don't necessarily have the resources to pay $200,000 a year for this Ethereum coder to maybe make something that might work, but might break in the future. And yeah. Wow.
Okay. About the IPFS, so I can just use your code to create my own YouTube on my website, or
pretty much. I'm building an internal search system right now for Ernie. So we're gonna. I just ran it on Nexus.io right now, but we're gonna just for the demo today, the Anarchast. But that can be utilized inside any internal website. And then I'm taking that code a little bit more, and I'm gonna add a public registry so that websites can register, kind of like old school search engines. Register your website, put some metadata, and then it'll run a bot to grab the site, check Summit, so you get some additional immutability, and then that'll create an open indexing for websites as well for kind of a global search. So what I'm working on right now is like an internal local search of your own IPFS database.
Right, and this you're doing this for Ernie and James Corbett and this is kind of the thing that Ernie's been screaming about at everybody for
Yeah, yeah.
for years. Where's my pirate box?
Yeah, and then I want my pirate box. I want my search. I need to search my IPFS files. I need to search. I need my grandma's shut button. Where's the just button? When's it gonna be done, Colin? Come on. So, we flew here together, and then, when we got there, he's just like, blah, 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 search. And I'm like, it's done. He's like, you sure? I'm gonna go put you out there, man. I'm like, yep, it's done. So, yeah, we got it.
So we're going to display this tonight on the Anarchast. So I guess if you want to go down to Beach Mart tonight at 7?
7, yeah.
At 7 p.m., we're going to be doing this live at Beach Mart and with James Corbett and Anarchast and Ernie,
and
all
Ernie
this.
and me, and Corbett, Anarchist, and then this is also you can do search on blockchain if you scrape the data into your own database, and that's usually what I've noticed a lot of other platforms do, or they'll cache files on their local servers. What we're doing is showing a pure decentralized open index, right? And I'm developing an initial algorithm, a search algorithm, and sorting algorithm, and ranking algorithm, essentially, that's open source, but anyone can take that same data set and create their own algorithms or their own windows on top of it. So it creates this fully decentralized indexing system that allows full searchability for files, and that sets the foundation for our file system, because IPFS is cool, but there's a lot of issues, like Bitcoin node incentive issues, right?
Right.
I mean, just even doing the search, it's like some of the videos take ages to load because it's not seeded, because, people only seed what they're watching, and maybe you got an IPFS node running or not, but there's no financial incentive for you, right? The internet is run on content delivery networks. So what if you take that and you democratize that and make that decentralized and into people's hands instead of corporation hands, and create an incentive system, which they tried to do with Filecoin, and they've tried to do with these other ones, but they've got some missing economic issues, so I'm not surprised they haven't.
Storage,
I'm
made
not surprised they
safe,
haven't
all of
come
them.
to fruition, because they've, the way that they're like, oh, we'll pay out on the block, and blah, I mean, it won't work. So I've been sitting in the background designing this file system as well. So eventually the decentralized search will kind of plug into all of that, and you'll just have a file system API on Nexus where you can just load a file into the file system API. It'll load out into the file system. You'll throw a little bit of Nexus into it, which will go out to pay contracts, hosting contracts for other people, so that you can create higher availability of your data, and when you're sharing it, and you'll get faster speeds, and you'll have incentives for other people to host your files.
Will like Start9 and these other tools be helpful in this? Or
Start9?
Yeah, it's a Raspberry Pi, kind of
Maybe
a group server, basically.
I don't know.
Oh, okay.
Yeah.
I know that's where Ernie's been wanting to put all this stuff is on. That's his pirate box.
Yeah, the
Raspberry
Start9.
Pi, yeah.
Raspberry Pis. Yeah, I mean, Pis can work. We're gonna be doing that too, just building little Pi nodes that you can fire up, turn your file system on. I mean, or run, spare disk space off your computer. I mean, that's one of the best things we can do right now in this climate with all the hyperinflation everywhere, is we need to create economic opportunity where there wasn't economic opportunity before, like you guys have been doing with the circular economies in Venezuela, right? That's the best thing we can do, because people can't eat, right? And when you can bring those economic opportunities into these different areas through simple things like, hey, I got a gig extra on my hard drive, or, I'm developing the circular economy from a master node or anything else. Those are some of the best things that I think we can do. So that's really what a lot of our technological focus is towards, is developing those economic opportunities for people around the world.
Awesome. Do you want to talk a little bit about the unstoppable internet without it taking away from your speech at all? Or
Yeah, I mean, so like I said, decentralize everything, right? Everything's fucked. Pardon my language. Needs to be decentralized. The internet, I've spent a lot of time with some of the fathers of the internet. The first fellow of Cisco, Dino Farinacci, was one of my mentors. And so I learned a lot about how the internet works and how it doesn't work. It's totally unauthenticated. You can be anybody you want. You just know, even email, it's just like, hey, reply to, here's my email address. You can send from anyone's email address. You can source from anyone's packets. Once I get on your local network, I can poison your cache, and I can totally read everything that I want and strip your SSL off. I mean, it's just, it was not designed proactively. It was more reactive design, kind of like Ethereum, and, I wouldn't say Bitcoin, because Bitcoin hasn't really been designed too much lately. I guess Segwit and Lightning are a little bit, but I wouldn't really call that design. It's just a new banking system. Hey, deposit my Bitcoins into this channel, and I withdraw them out of this channel after I use them on the payment network. What's that? Bank payment network? What? Yeah, PayPal, exactly. But so, democratizing the actual hardware of the internet is really fundamentally important. I mean, because right now it's run, I don't know if you guys know, there's big giant cables strung across the ocean floor. Not kidding. When I found this out, I'm like, what? Like, that works? Like, don't sharks bite it? Yep. They bite it all the time. Like, don't you have to guard those because other countries could, like, start running tapping cables on it and side channel attacks? Yep. So now you have a justification for the narrative of, like, oh, hey, we need to control our cable locations. But when you control your cable locations, hello, Cuba, right? What happens? Oh, the cable broke. Shark, sorry, you guys got no internet. You can't talk to each other now, right? So the internet is designed to be open and decentralized, but the architecture, kind of like blockchain, has not fulfilled that vision fully. It's partially fulfilled that vision. And we're starting to see a lot of those things break down. So I've been, since about 2016, designing a new internet protocol as well that basically renders IP addresses obsolete. It's kind of like a geospatial routing system, and it utilizes ground-based mesh networks, high directional gain to solve the RF saturation issue with mesh networks, open, unlicensed frequencies, so that basically it's pirate radio without having any legal liabilities. I've found ways to do pirate radio without being a pirate, but it's still a pirate radio, and they can't do anything to stop it, right? Using the right antennas and the right frequencies, and then add the routing system, and then the satellite file system and all that. So that it's designed really to be, hey, I buy this router, I have to pay a bill every month for the conventional centralized internet model. It sometimes works. Customer service is the worst in the world for ISPs because they got monopolies. They don't care, right? And, if you look at some of the richest people in the world, what do they make money? Like Carlos Slim. He got the telecommunications monopoly from Mexico. Then Carlos Salinas, he privatized the telecommunications system and gave it all to Carlos Slim, and one of the richest guys in the world, right, because of Metcalfe's law. So what it basically is doing is trying to capture that Metcalfe's multiple connections, exponential growth and value, while also democratizing the hardware where it becomes owned by different people around the world as this type of open protocol that makes you money rather than costs you money, right? So your hardware becomes more of an investment vehicle rather than just a cost to access something, right? And that's going to be really important for us to have that freedom of communication, because just a little side tangent, I was kind of studying, like, well, the ancient world's really cool, right? There's Library of Alexandria, you got Egypt, there's all this cool stuff. And then it's like you got the Dark Ages. And all of a sudden everyone's, like, shitting in these weird castles. And, I mean, like, it got really bad. And it's just, how did the world go from this knowledge to just this darkness? And I really looked it up. It was because the collapse of the Roman Empire, the roads went out of service. And people stopped traveling. And what that means is information stopped being exchanged, and then libraries got burnt. So really, if you look at the foundation of golden ages, right, it's based around knowledge and exchange of knowledge, right? So the internet's becoming more and more difficult for us to freely exchange knowledge, and we're looking for new and new methods, right? We've got IPFS now, but how long is that going to last? I mean, look at torrents, man. I mean, back in the day, I used to download, but then they actually get people, remember, seeding, and then they'll start sending you the threatening letters, and it's just a matter of time before they really start to try to lock it all down, because they own the IP address allocation. Domain names are regulated by U.S. authorities like ICANN, right? VeriSign actually owned COM, and there's a little corruption with VeriSign where they're able to increase the the cost of comms ad infinitum now because of all of that. So the internet just technologically hasn't reached that fruition to, I guess, reach that prime goal of decentralization that I personally see it was designed for. And the openness of it has become a problem, right? It was designed to be this open protocol, but when you don't have those access controls, you create all these additional issues, and then down to the operating system level even, right? They're just all flawed. They're all monolithic kernels. I mean, Microsoft started with DOS, which was really just they bought disk operating system from some random guy because they bullshitted IBM, right? That's the start of Microsoft. They wrote the NT kernel, which stands for New Technologies. It's like, I don't mean my friends laugh about that, but like, there's really not been much done in that level, and microkernels haven't really made it either because of different things. So we're focusing on just all levels.
So your guys' version of the unstoppable internet kind of predates Elon, right? I mean,
oh, yeah,
the ideas came from you.
Way before
Hey, if
Elon.
you guys don't know, his dad actually was a co-founder of SpaceX, so he is a rocket scientist, and they were wanting to launch CubeSats to have this free internet for the world, and now Elon's out there with it. What do you see Elon's version of the internet? You think it's good or bad? Or?
I mean, it's the old internet. It's just a centralized economic model. I mean, he's trying to solve the issue of the 5 billion people not connecting to the internet, but he doesn't understand it's an economic issue, not a technical issue, right? Because who's going to go put copper and fiber in Venezuela and everybody's broke. Nobody's going to be able to pay the bill, right? Facebook tried to do it. Google tried to do it. People aren't connected because they don't have the economic means to do so. So we're solving it on the economic level, right, through this, and then creating tokenization mechanisms where you can actually crowdfund these satellites together and own pieces of the satellites and share in the revenue. So you're going to create all these new free market dynamics within it, right? And then it becomes a people's internet. And that's where it's a no-brainer, man. You got Sarnoff's law, centralized, V equals N, right? V equals N means it's a linear relationship. 1, 2, 3, 4, 5, right? Metcalfe's law is V equals N squared. 2, 4, 8, 16, so on and so forth, right? So you've got this. You know, at first, it's you know, we're a little bit behind Elon on our satellite deployment, but once we get it, it'll surpass him, and then it'll just render him obsolete because he's just building another centralized model, right? Who needs that? Like, we got another ISP, whoop-de-doo, yeah, I can get internet somewhere I can't, but that already happens just with geosynchronous satellites. The only thing he's really trying to solve is the bandwidth latency issue, and that's really somewhat important, but I mean, I've used satellite internet for decades, man, like DirecTV and whatever. I mean, that's what we used to have in Utah because we live so far out in the boonies, right? I mean, it works. You just got a 1-second ping because you're about, I think it's 17,000 miles out in geosynchronous orbit, right? So you got a 1-second round trip time, but that's all he's really solving. But it's also my personal perspective. If you read the terms and conditions of Starlink, okay, there's specific clauses in there that give Elon claim to Mars. So when you buy Starlink internet, you're actually telling, oh, Elon, Mars is yours. So it's a bit of a sham, you know. And then
who
when
wants
put it
that
up,
shithole anyway?
I know, dude. I mean, and then when you put it up,
Have you been there?
and I know Elon intimately, and I'm not going to say anything too negative. I don't respect the guy. I don't think he's as smart as the smartest employee, right? He's definitely got a very strong drive to fulfill what he sees, and I can say I respect that. All the other stuff, personality stuff, not so much. And then you see that leak through these little nuances. Plus, the rocket science stuff is cool, but I think strapping bombs to our ass and hoping for the best is probably a little old school. I think there's different ways when we're looking into exploring the stars, exploring asteroids. We need to find some sort of electrokinetic reaction where we can turn electricity into propulsion. There's ways to do that with ionization and other different means, asymmetric capacitors, which studying. So, like, you know, he's legacy to me, right? And legacy is going to go down with the legacy stuff, right? He's not thinking in this new innovative way, which is, I think, what's required to make this happen. And that's what I think is so beautiful about this decentralization of this whole industry. All the big guys are lost puppies, man. Like, they can throw as much money they want at the wall, but it's not about the money. It's about how you can think and learning to think that way, right? And creating these truly decentralized, you know, markets. And you know, that's something that I don't think they can really have, and that's something that we render them almost obsolete just through that simple product. I mean, like Mike from BEF, right? The carbon credits trading platform is taking on these guys in Singapore that are dumping millions of dollars and building their own carbon credits trading platform on blockchain, and they don't believe that he's actually done it, just him with a no-code tool bubble and a secret weapon Nexus, right? So it's just we're more agile and fast, and we can solve these problems because we have to think in that new way, and that's what humanity needs.
When will we see a Nexus internet?
I'm working on the basics of the operating system right now. I've got a couple of Adrenos that are just like a little teeny programmable microcontroller that you can code some C++. I got 433 megahertz transmitters and receivers and GPS. So I'm going to start building the GPS routing system and mapping system on Adreno hardware. That's happening this year. I'm working on the parametric resonant for the hydrogen and then electrokinetic with asymmetric capacitor stuff. So this year I'm having some basic prototypes developing the routing system specifically, and then that's going to go into the operating system, which is based off of the SEL4 microkernel, which has already been hardened and proved to prevent drones from being hacked and other. It's got a lot of military applications. It's a super hardened, super simple microkernel. And Nexus is going to do most of the heavy lifting. So I'm shooting to by end of 2023, 2024 is when we want to start seeing some stuff churning as far as like satellites being deployed, tokenization happening.
Maybe some mesh networks first, just to test it out.
That's what I'm doing with the 433 megahertz Adrenos, right? I'm building an Adreno mesh network with a little thing where you can type and send messages to each other, and that's to develop the actual router, right? And that's going to be written in C, so I want to develop that and model that on real hardware because it's a stateless routing system, which means, like, if I want to send a message to Arizona, let's say, I'm going to have to go hit the router here. That router is going to go to the next ISP router, which is going to go to the next router, and it starts with the big number, and it kind of hones in on exactly where. What the IP address is really functionally doing is giving a machine-readable number that maps to a physical location, okay? But it's acting as a locator and an identifier. okay, what we're doing is we're separating the locator and the identifier, but we're making the locator not a machine-readable IP address that has to be loaded into every router. Mind you, again, it's unauthenticated, so if you get into somebody's router in an ISP, you can be like, hey, I'm going to put whatever IP addresses in here I want, right? It's just totally unauthenticated all across the board, so you've seen parts of the internet go down because of that. So this is a stateless GPS routing system, which means you don't need to have all these IP addresses loaded on all these stupid routers that are always, if you think about this dynamic, changing, moving system, you can't like change the IP address every time. Like someone go, oh, yep, I'm gonna load a new IP address over there now that you're over there. Oh, wait, no, you're there. I'm gonna load that over there. Think of all the overhead, right? You'll spend more time just keeping synchronized with the IP addresses than actually transmitting data. This is a stateless routing system. We say, okay, Danny, I'm here. We need to go to Arizona. Oh, we got a satellite up there. I'm gonna shoot it up there, right? Satellite's gonna receive it, and it's gonna be like, okay, the GPS coordinates, 33,111, right? Those are the GPS coordinates of Phoenix. Okay, where am I? Oh, that satellite over there has the lowest cost of that GPS coordinate. Goes to the next satellite. That satellite says, oh, that satellite I'm connected to has the lowest cost. Yeah. And then you get to 33,111, drop down into the ground system, and boom, your packet has transmitted without actually having to have IP addresses loaded onto all of it. And it's stateless, meaning you don't need to know anything other than where you are and where you're going. And you utilize the state that exists in physical reality already, aka GPS coordinates, right? That allows you to essentially function with the same principles that packet forwarding, packet switching does with IP, but without needing all that IP. Because if you have to upload IP addresses, you have to have some sort of authority for the IP addresses, right? You have to have some way to manage those IP addresses and allow who owns this IP address, who can update this IP address, and then you have to have a database to store it, and then that database has to be sharded, and then you have billions of records, and then how are we going to store them on set? You know, the problems get bigger and bigger and bigger and bigger and bigger when you're dealing with IP. But this is nice and simple and elegant, right? It just point and shoot and fly as a crow flies and go, right?
Wow. I think I got information overload here.
I talked slower today.
I know you did. At least no one complained today about it.
Yeah.
I feel like I left like Nick completely out of this. Nick.
No, it's cool. It's interesting to listen. You're incredibly intelligent, so I actually do understand a lot of what you're saying, believe it or not. But you know, I've been a developer for like 12 years. Not that kind of developer, but I understand, you know, the basics of what you're saying.
This is Raymond, and that's Rain Man. But just kidding.
Now, here's the thing, though. Like, while I agree with everything you're saying and the outcomes that we're aiming at are the exact same, getting there is going to be difficult. I think we have to acknowledge the fact that a majority of humans that are in business still adhere to the Milton Friedman stakeholders, shareholders are king doctrine, right? So regardless of, you know, we could build as many technologies as we want, but without consensus of people that want to actually use those things, we are going to continue to perpetuate the same systems that we have already built, right? So it's changing of the minds, and exactly, and I think one of the coolest examples that I just heard that kind of like makes this a little bit more tangible to understand is the coffee bean farmer example. I was interviewing this guy on our podcast the other day, and he has this similar solution, API-driven solution, that could probably be accomplished with Nexus as well. He said, when you go to Starbucks or whatever, your local coffee shop, and you drink that cup of coffee, you don't think about where the beans came from, and really the only person benefiting from it is the distributor and, of course, Starbucks and a bunch of administrative middlemen that facilitate the supply chain of those beans, right, to the cup. With what you're building and what we're promoting in cryptocurrency and decentralized, infrastructure, it would allow for the mitigation, or in some sense, elimination of a lot of those middlemen, right? So instead of me just going and saying I want a cappuccino and then leaving, I can actually go and see on, like, let's say a phone app, mobile app, where the bean came from, who the person that actually farmed that bean and put it in a bag was, and I can see his face and I can see his farm. And because there's no administrative cost along the supply chain, that cup of coffee costs me a lot less. And I can contribute to that individual directly, right, with cryptocurrency. And that individual can start to become a more significant and substantive part of his local economy. And then, as he becomes a more substantive part of the local economy, and the rest of his, colleagues on his farm do the same, we can start building those roads. They can start engaging with infrastructure, and they're not going to think about the current infrastructure, right? Like a lot of us are probably from the US or first world countries here. We're disrupting an ecosystem and an infrastructure that has been in existence for a long time. It's really hard to battle against that. Somebody in a remote village in Costa Rica or Sumatra, they don't know that. They don't know that the internet has existed the way that it exists for us for a long time, right? There's no disruption needed. They are adopting as it's happening, right? They are adopting this new technology firsthand. It's all they'll know. And as they become more and more wealthy as a result of this democratized financial system that we're building elsewhere, then they can reap the benefits and the rewards of said infrastructure. And I think, to me at least, that's the path towards getting this stuff actually in the right people's hands, right?
In a way, you give power back to the people, right? You solve the economic issue. People in villages, they can't get ISPs because nobody's running copper and fiber there, right? But if you can just buy this thing as a little community, crowdfund it, and boom, now we have Wi-Fi. Now we can connect to the internet. Oh, wait, now we can sell that Wi-Fi to our neighboring village, right? And create a mesh network, and now we've got economic benefit where we didn't have it. That's why Facebook, Google, and Elon with Starlink are never going to succeed in getting those 5 billion people connected because they don't have $100 a month. That's what he's trying to charge, $100 a month for the internet. They don't have that. You know, we need to create those opportunities because people are going to build it. It won't be decentralized if one person builds it. Everybody else has to build and deploy that open source protocol. And that's where you capture Metcalfe's. Remember the V equals N squared, the exponential growth and value in the system. And that's why people like Carlos Slim, they become so wealthy off of telecommunication systems because they're so lucrative in that human connection element, right? This way, we can capture all of that economic value and give it directly back to the people instead of costing and taking from them every time. And that's really fundamentally what needs to happen. And there's so many places in the world that are just completely isolated from those things because they don't have that economic. They've spent a lot of time using the borders to destroy economies so that they can have places they can pillage resources in for nothing and control the people very easily. And it's
exactly what China's doing right now.
Yeah,
right?
yeah. This transcends all of those borders, right?
Right.
Yeah, it's fundamental. Yeah.
China understands this, though, right? That's why they're going in and colonizing parts of Africa, basically turning them into Chinese nations, right? Because they know that if they create a middle class, they can increase their overall GDP and reap the benefits of a new class of individuals that is outside their multi-billion resident ecosystem.
Yep.
But that's the other battle we fight. Right, it's like, okay, we have these big tech corporations and big, multinational organizations.
And then
and China, right? Yeah. But it can be done because of Metcalfe's law.
Yeah, exactly. And that's what puts them all out of business, too, because, like, okay, well, why am I going to pay for your stupid Starlink ISP? You know, I can just go earn some money off of this one, or I can buy the hardware, and now I got free connection, right?
I mean, look
or
at
I
Axie
can go
Infinity,
crowdfund. What's
right?
that?
Axie Infinity is a perfect example of this. There are literal, farms of people in the Philippines that are playing Axie Infinity for a living, right? Because they were able to give players back some of the earnings that they make instead of the model that we have now, which is basically pay the video game operators to get better levels or whatever. Yeah. It's a small example, but that's the precursor to what we're talking about.
Yeah, and it fundamentally, too, the best thing we can do for people is teach them to fish and give them tools to fish because what all of these big governments are trying to do is give them fish and get them addicted to their fish and then put fluoride in the fish and everything else, right? Yeah, I'm making a joke on the water and the fluoride in the water that calcifies your pineal gland, right? But, there's all these things that they want to centralize and control all of that because they need to create gates and roads in order to funnel all of that through. And that's why we need to really, on every level, we need democratized power, too. Like, look at all the electric stuff coming out, right? There's not enough lithium in the world to produce enough batteries to actually run the world on electricity, let alone your Prius that you think is going to pollute less actually costs more pollution to just create the damn batteries and mine the lithium, right? Right? Lithium is a very it's got a lot of medical benefits. What the hell are we taking it out of the ground with so much water and trying to run into these stupid batteries to get memory and die after like so long? I mean, it's like the biggest planned obsolescence of every phone, the lithium batteries, right? So we need to focus on all of these fundamental technologies like our own power, our own communication, our own kinetic movement as well, right? And phase ourselves away from some of these old centralized technologies. And that's where I think that's what's really going to change things, is when we put those things in people's hands and we make it open source. I mean, there's multiple people that have figured out different technologies. Like Stanley Meyer had worked on, you know, a parametric resonance of the water molecule, and he claimed to have a car running on water. But he was killed because he tried to do it as a company. He tried to save the world, right? And that's the problem. That's why all these guys get picked off, is because they all want to claim some ownership in it. But when we can go with that new way of thinking, right, the decentralized way of thinking of like, I build it, you can have it, right? Build on it. Then that cannot be stopped. When I talk about unstoppable, man, you give it out to everybody and make those blueprints open. People add on it. They build on it when you have an open index where you can actually accurately reflect that information and show how that information has changed through histories, right? Such as like a decentralized peer review system for scientific documents. Then you remove all of that corruption around there, and technology is just going to go through leaps and bounds, and people will have the tools, and it will be unstoppable. It's already unstoppable now. We just got a little snowball. This little snowball we got here, but there's little snowballs like this growing all over the world. And the more and more we discover each other and the more technology we can build, the more we're going to be able to recognize each other, and that snowball is going to grow. And we're getting to a point where our snowball is bigger than theirs, and that's when they're fucked.
That's right.
It's unstoppable.
That's right.
I think that's a great note to close on. It is unstoppable, and that's the name of this conference. And so this is Nick Saponaro from the Divi project. Great guy. Definitely go and catch him. He has a booth, but he's not operating it. And Colin with Nexus.io. They're great people, great projects. Check them out.